Welcome back. Let's continue our discussion about the data objects and the data that they contain. Each data object contains data about the event that took place. Now, there is specific data that is captured for every event. There are some specific fields that are object specific, and which kind of makes sense when you think about it. If I were to deal with a file type object, I'm talking about files on the computer. Those are different pieces of data than I would get if I was talking about a registry type object, or if I was talking about an indicator type object. There's going to be common data across all the fields, but there's also going to be individual data that is specific to the type of object it is. Process data is a little bit of a special case. In almost all cases, in almost all 12 of these, the event happened because of a running process on the system. And so the data for that process is generally collected where appropriate for each one of these. Now, we're not going to go through all of the fields, but we're going to give you a little bit of an example of the kinds of pieces of data that we do collect. The common data is very much the kind of data that you're going to get all over the place. We're talking about where it happened, what the operating system is. We're going to gather things like agent version, the object type and event type, and when it occurred. So this is pretty generic information, but it's what you'd expect to see if any type of event occurred on your system. These would be the common fields that you're going to gather each time. The process data gets to be a little bit more robust. I broke it down into 4 basic categories. And that's basic process information, which talks about name and a couple of other things. Process run data, who ran the process, when it ran. Hash values. We're going to talk about how when a process runs, we're going to hash various portions of it. Hash the files, we're going to hash some of the command prompts. And this allows you to find very specific instances of a process across your network. This can be very useful if I'm looking for a particular malicious process. Did this process run on more than one system? If we've hashed the process values, then I can be very specific and say, I'm looking for this hash across my entire network. And since we're hashing all of the processes, we'll find it. Then, of course, there's more detailed information about the process itself. We go into all kinds of information that we can search through. This is it listed out. Again, I'm not going to go through all of these names. It's a bit of an eye chart. I understand that. But as you can see, for future reference, these are the actual names of the data that we actually gather for each of the processes. I realize this slide looks very similar to what we just saw earlier, but this time I'm talking about the individual types of objects, and I'm showing the data that each one collects that's unique. And as you can see, for the most part, it makes sense. I mean, if we talk about network actions, we're looking for source and destination IPs, source and destination ports, the direction of the connection, the status, is the connection still functioning or not, and the name of the system or the file that actually opened up that particular network connection. Files, paths, descriptions. In this case, though, remember there are things where you're talking about new and old. This is important information because if a file gets modified, then we want to be able to maintain what was the file's function or name before the file was changed with this particular event. And by having the old name and the new name and the old path and the new path, we can know when things got moved or when they've gotten changed. Also, we have the hashes and the MAC times. We know what all that information is. Under detections, we have the name and category. Logins, username, of course, the type of login, and it would depend on the type of machine. There's different operating systems have slightly different bits and pieces of information when it comes to logins. Under the URL, we grab the URL itself and the action. This is a little bit more of a unique situation. This is something that we actually can't do with the agent. There's actually a plugin for the various browsers that grab the URL and grab that information for us. So if you don't have the plugin installed in your browsers, you will not gather the URL information. That is something you might want to think about if you are doing your setups to make sure that that plugin does get installed across the board. DNS gives us the request, which is nice. Scheduled task gives us the name of the scheduled task and where it is. Registry information, like the files, we have new and old for all of the registry information, which means that we can tell you what the registry was and what it was changed to with each event. Modules, basically where the module is and the hashes. Indicators. We'll talk a lot about indicators as we go, but indicators in this case are when we decide we see something that looks a little weird, we may actually create a specific record for that. Now, it's the AI doing this. The AI actually looks at this and says, hey, I don't like what this is doing, or I think this is going to be a little bit weird. And so we are going to create an indicator about it, and we're going to store that information. This does not necessarily mean that we're talking about a malicious action. What this means is doing something that is similar to what other malicious software will do. If there's enough indicators, the AI will go through and mark it as either suspicious or malicious. But just one or two, most normal software actually creates several situations where indicators happen. Command scripts, we actually grab the script text, or at least as much of the text of the script as we can. There is a limitation to the size of the field, and if the script is too long, we will be unable to gather all of that information in the record. If that does happen, there's a little checkbox that says, do I have the whole script? And yes or no. And there's a Boolean that it gathers as well. Again, also with the SHA-256 and what application actually ran it. So very good information gathered about each of the data types. With all that information, we do have a great deal of data that we can search through at our leisure. And to do that, we have to go to the Deep Visibility tool, which is pictured at the top of the screen there. That's what the actual screens look like. As you can see, there's a place where we can type in our query, and the results show up down below. We'll show this in an example in a different video. There's a bunch of different ways to get to Deep Visibility. The most main one is to click on the magnifying glass, as you see, that is circled by or enclosed by the purple square. That'll take you to the screen that you see above. But there's actually a lot more ways to get there. If you have been going through the videos before, we talked about the left click options that you have when you're looking at different areas of the software, most notably in the incident area. If you left click on those, as you can see, you get an option that says Open in Deep Visibility. We'll show this more in an example later, but what this will do is automatically generate a query for you inside the visibility screen and then run that query to give you the data. We'll talk about that in another video. There's also a Find This Hash in Deep Visibility. So in other words, there's literally a Hunt Now button, as is pictured here, inside the incident, and that will allow you to hunt for the malicious activity that you have been investigating. Again, more of this in the examples. The syntax is actually very easy to understand, and we'll go through it a little bit more in depth when we go into the examples, but more or less there's only three things. There is a field to search. In the first example there, that is the endpoint name. That's the field we are searching. How we plan to search it. In this case, the top example, we're looking at the equal sign, so we want an exact match. And then something to look for. So I'm looking for some name in endpoint name. So I'm going to search through all of my records that have endpoint name, and I'm going to search for some name. Now, with an equal sign, it needs to be exact. It has to be a capital S, can't have a space, it has to be a capital N, and exactly as you see it. If I found some name with a small s, would not match in this case. So we have multiple ways to search. You notice the next example down, instead of having equal sign, I used contains any case. In this case, some name has to be in there. Now, it could be Rob's some name or subname equals Fred or something. It doesn't matter. As long as SOMENMME exists somewhere in the name of the endpoint, it'll be returned. You can also do things like equal to, greater than or equal to, less than or equal to, and things like that. You look at the next example there where destination port is greater than or equal to 1024. You can use nots. Destination port is not equal to 3989. Notice that all of the things that we're searching for are in double quotation marks. We can also put things between things. The destination port is between 32,500 and 65,000. That works as well. Sometimes it gets a little bit weird with Boolean type values. The target file is executable. Simply true or false. And as you can see, it is true or it is false is the other option, which is not actually shown. You can do ends with or starts with. And probably most important of all, you can use regular expressions. So if you have a very complex thing you'd like to search for, or a complex string, not a problem. We support regular expressions that you can utilize to look for exactly what you're trying to find. So even though it is not a complex interface, we do provide as much help as we can. First of all, autocomplete. Hugely helpful. If you'll notice at the top left-hand side there with the E, I just literally typed in the letter E, and it shows me all of the options that contain the letter E. I can highlight them, move up and down the list with my arrow key, and then find the one I want, hit enter, and it'll automatically type it in for me. So I don't even have to type all the letters in. E is all I need. You'll notice in the box to the right, I've actually done so. I've hit enter, and then I've hit space, and I've hit tab again. I don't even have to know which types of comparisons exist. It will show me the exact list that's specific to the name I just selected. In this case, endpoint name is a string value, so I get string value comparisons in this list. However, if it was a numeric value, I would have gotten the numeric value comparisons. If it was a Boolean, I would have gotten simply the Boolean comparisons, and so on. Very simple, very easy. Now, obviously, when it comes to what I'm searching for, there's no autocomplete there in most cases, unless it is a type enum, in which case there would be a listing of all of the possible enumerated options for that particular variable. We also offer some starter queries. When we get into the example, I'll show you how some of these work. And we're just trying to get you started and get you moving. Different things you can look for, things that we know that we've been utilizing in our own use of the software, new and exciting attacks that you might want to search for on your network, things of that nature. We offer starter queries that you can simply click on, and it'll put all the query information into the fields for you, and you can just hit enter and allow it to search. Very simple, very easy. Remember the left-click menus? Well, when you left-click on one of those menus, it actually does create the query for you and put it into the fields. We'll experiment with this later. Finally, last and definitely not least, there is the Hunter tool. The Hunter tool allows you to search the internet, find web pages with interesting information you might wish to search for on your computer, and then it'll scrape that information into the system and create a search off of that information just for you. Very nice. So over the next series of videos, we're going to do a couple of demonstrations. First of all, we're going to introduce you to the interface itself in a live demo in all the different areas that you can get into. We'll talk about simple queries first, and we'll type in a couple of them to get your fingers used to how those work. Simple queries generally do not provide succinct information, and you'll have more data than you'll want to see. So we'll talk about how to sort and filter the results that you get from our simple queries. Finally, we'll talk about the tree view, which if you've taken and watched the other videos, you've seen a very similar view in the incidents page. This, however, is going to be an expanded version of what you saw in the incidents page. So strap in. We've got a bunch of different videos to go through, and then we'll move on to some more advanced usage as how you can make this work in your environment.